Alright, we're looking at GCO2, and this video deals with worksheet number 2. As you can tell in these early stages, we're dealing with a lot about new terminology and how they fit together. A good teaching technique is always to relate something you know to something that's new, and that's certainly what's going on in these early objectives. We're going to talk about a function and a one-to-one function. These are algebra items and should be reviewed to you, and hopefully they will help you to understand these geometry items, which are called mapping and transformation. Ultimately, the real important word here is what is a transformation. So we're going to lead to hopefully obtain that here in this first bit. So let's start with reviewing what a function is. Basically, a function is for each x value, there is one y value. Now that can be said a couple of different ways. This is speaking about x and y. You can talk about for one input there's an output, one output. You can talk about for one value in the domain there's a y value in the range, and so on. There's lots of ways to describe that. There are diagrams that we often use for this. So sometimes we'll diagram the domain, say, and we'll diagram the range like this. And we'll say for each item that you have in the domain, there has to be one y value over here. And so this can take on different looks, like maybe something like this. We'll discuss this here in a second, but just giving you an idea, here we have three items in the domain. This one goes to this one, this one goes to this one, this one goes to this one. And even though this is usually one, students say, no, this isn't a function. It is, because for each x item, there's one y item. This one has one, this one has one, this one has one, and so on. Well, let's look at a couple of those diagrams, because they're often helpful. So the first one here is probably the easiest function. For every value in the domain, there is a value in the range. Or for every x, there is a y. And you see it there, and yes, of course, that's a function. Now, as I already hinted to, lots of students see this diagram and want to say, no, it's not a function. This is a function because for every x, there is a y. For every x, there's a y. For every x, there's a y. For every input, there is an output. Now, yes, they have the same output here, but B still has an output, C has an output, A has an output, and so on. So it's a yes. Here is where we get kind of the counter example, or the no example. Here's why. Notice this. A has a D value, but A also has a G value. This is not a function, because this x value has two y values. Remember that definition? Let's take a look at it again. It basically says for each x value there is one y value. And so this is a no, 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 no answer. This one again is like this one above it, just simpler. A goes to G, C goes to G. Yes, this is a function. Now, mapping is the same thing, but in the geometry world. Mapping just means to go from, but we're talking about points in the mapping world. So it's like saying, all right, if we have a triangle, it has 3 points. We can map that to a triangle with 3 points. Now this example here is a lot like this one in our function world, where 3 points went to 3 points. Right? That's a function, and that's a mapping. 3 heads to 3. Now, the problem with mapping is that this is also a mapping. You could take your triangle with 3 points and we could map it to a segment with 2 points. This is a lot like this world. You see the 3 points here and then the 2 resultant ones. This is okay because this point could go to this one, this point could go to this one, and this point could go to this one. This is still classified as a mapping. We don't like this, but it is a mapping. What isn't a mapping is when you take your points, let's say your 3 points, and map it to something with 4 points. This is no good. This is not a mapping. For the same reason that here we can't go from 2 points to 3 points. And here's why. This guy goes here, but this guy is forced to go to 2 places. Same thing here. Maybe this guy goes to this point, this guy goes to this point, but watch what happens. This one would be forced to go to 2 different points, and this is not mapping. These two things are the same. We call it function in algebra, we call it mapping in geometry. Now, truth be told, we're not interested in mappings in general. We want triangles to stay as triangles. We don't want them turning into segments and stuff like that. Let's take a look at what a mapping, determining mappings might look like. So here we start with 3 points and we map to 3 points. Yes, this is a mapping. Here we start with 3 and we map to 2. We don't like this, but yes, this is a mapping. Here we start with 3 and we map to 4. Oops, this is not a mapping because, again, somebody would have to go to 2 points. This is not a mapping. And here, again, while we don't like it, yes, this is a mapping. 3 points going to 1. Now again, we're going to fix this because we don't want this to happen in general. This is a mapping, but we don't want this to happen. Yes, this is a mapping, but we really aren't interested in this. We like this environment. Therefore, the final 2 words, I know this is pretty technical, hang in there. The final 2 words, one-to-one function. That is the beautiful world when everybody in the domain goes to exactly one distinct, one distinct y value. In other words, that guy's got to be all on his own, used only by one. A one-to-one function. That's what that is. That's what a transformation is a one-to-one mapping. In other words, 3 points go to 3 points. In other words, 4 points go to 4 points. In other words, 1 point, or let's do 2 points, go to 2 points. This is the world that we want to exist in because this is where we keep things consistent. So this lesson was based off of the idea of the 4 different terms. Function is the same as mapping. One-to-one function is the same as a transformation. What is a transformation? It is where it's a one-to-one mapping. In other words, for every point you start with, you finish with a point. Let's finish with a couple examples there. Alright, here we have 1, 2, 3, 4, 5, 6 points. Here we have 3. This is a mapping, but not a transformation. Because 6 goes to 3 is a mapping, but it is not a transformation. This one has 1, 2, 3, 4, 5, 6 points again. This one has 7, I believe. This is not a mapping, and this is not a transformation. So what is a transformation? This beautiful thing right here. 4 points go to 4 points. Yes, it's a mapping, and yes, it's a transformation. Now I know that these are difficult, always have been, always will be, but I guess the key to understanding, or a quick review, is a function is to a mapping as a one-to-one function is to transformation. When we say transformation, Means we begin with a certain amount of points and we will end with the same amount of points.